Hello everyone, this is Chrizzel I'm Sarroza, and I am back with another video. This time, I will be discussing about the terms and definitions related to fiber optics. Okay guys, this report is a bit different because I will choose 3 topics and the terms that I am about to discuss are based on my first name, middle name, and last name initial letters, which are C, M, and S. So now, without further ado, let's begin. Okay, so here are the terms. C for critical angle, M for empty RJ connector, and CS for star network. First is the critical angle. So the angle at which light in a high refractive index material undergoes total internal reflection. In geometric optics, at a refractive boundary, the smallest angle of incidence at which total internal reflection occurs. In physics, the critical angle is described with respect to the normal line. In fiber optics, the critical angle is described with respect to the parallel axis running down the middle of the fiber. Therefore, the fiber optic critical angle is equals to the 90 degrees in physics critical angle. Okay, so Snell's law indicates that refraction cannot take place when the angle of incidence is too large. Figure 1 presents 3 light rays in a glass block. Light cannot get out of the glass if the angle of incidence exceeds a value called the critical angle, where the sign of the angle of refraction would equal to 1, which is ray 2 to 2 prime. Instead, the total internal reflection bounces light back into glass, obeying the law of reflection, which is the ray 3 to 3 prime. In figure 1, light is refracted in ray 1 to 1 prime. The light is refracted when passes from glass to air. In ray 2 to 2 prime, the angle of incidence equals the critical angle which light travel tangent to the surface of separation. And ray 3 to 3 prime, the angle of incidence exceeds the critical angle. So light will be reflected back in the glass, that is the total internal reflection. So the critical angle can be deduced from Snell's law. So the equation would be critical angle equals to the arc sine of n air over n glass. When light tries to emerge from glass, which is 1.5, into air with equals to 1, so the critical angle is equals to 41.8 degrees. Okay, next. So the empty RJ connector. MTRJ stands for Mechanical Transfer Register Jack. MTRJ is a fiber optic cable connector that is very popular for small form factor devices due to its small size, housing 2 fibers and mating together with locating pins on the plug. The MTRJ comes from the MT connector, which can contain up to 12 fibers. A MTRJ is very efficient, high density, low cost, and lightweight optical fiber connector that has become widely used in network hardware. The design of it is very close to that of the RJ45 connector used in Ethernet networks. However, this is smaller in size and consequently lower in cost. It is slightly smaller than a standard phone jack and is very easy to connect and disconnect. Compared to older types of fiber optic connectors, the MTRJ offers lower termination cost and greater density for cable management hardware. So MTRJ connectors work in the same way that any fiber optic cable does, with modes of light traveling parallel with the fiber and their photons by vibrating perpendicularly to the fiber. At its end, each empty RJ connector has an RJ45-like endpoint that is slightly larger than a telephone jack and can fit into the Ethernet port on any computer, modem, or wireless router. Empty RJ connectors are advantageous because they allow users to take advantage of the fiber optic data transfers speeds without purchasing any special equipment or installing specially designed fiber optic systems. Empty RJ connectors are fairly inexpensive and can be connected to any Ethernet-enabled hardware in the same way that an Ethernet cable can be. So, empty RJ connectors are used to provide fiber optic speeds to personal computers, servers, commercial workstations, wireless routers, modems, and other devices that have not already been equipped for use with fiber optic cables. Empty RJ connectors are therefore a type of hybrid connector between a fiber optic cable and an Ethernet cable. Okay, and lastly, we have the star network. A star network in which all terminals are connected through a single point, such as a star coupler or concentrator. So, a star topology is designed with each node connected directly to a central network hub, switch, or concentrator as shown in the figure 1. Data on a star network passes through the hub, switch, or concentrator before continuing to its destination. The hub, switch, or concentrator manages and controls all functions of the network. It also acts as a repeater for the data flow. This configuration is common with twisted pair cable, however, it can also be used with coaxial cable or fiber optic cable. So, the advantage of the star networks are easy to install and wire, no disruptions to the network when connecting or removing devices, and easy to detect faults and to remove parts. While the disadvantages requires more cable length than a linear topology. If the hub, switch, or concentrator fails, nodes attached are disabled, and more expensive than linear bus topologies because of the cost of the hubs, etc. Okay, so next are the applications of the star network. First is most used and popular topology using LANs. The star topology was first seen by ArcNet. Next is used in small networks, used also in small organizations. Used in LAN connections for high speed up to 100 Mbps. Also used in small institutes, and all devices are connected to each other via hub or switch. Next is all nodes are connected to the central hub, and if any node is failed, doesn't harm or damage the entire network. Next is quite cheaper compared to other network topologies. Very easy in maintenance and up in gradation. And lastly, the scalable node can be added anytime user request or demand. Okay, so that's the end of my presentation. Again, I am Chrizzel and Sarroza, and thank you so much.